All right, I want us to check this concept here of Newton's second law of motion in terms of momentum. So it says that the net resultant force acting on an object is equal to the object's rate of change of momentum. So if we go back to grade 11 and recall Newton's second law of motion, it says Fnet is equals to ma. Okay, so this is the famous Newton's law equation. So now we have to take this formula and then put it in terms of momentum. Okay, so now we know that acceleration is equals to change in velocity over change in time. So if we substitute this acceleration on the formula, it means we're going to have F net is equals to mass multiplied by change in V over change in T. So when we multiply that, it means we're going to have mass multiplied by change in velocity over change in time. So remember, change in V it says V final minus V initial. Okay, so it means now we can say F net is equals to mass into V final minus V initial over changing time. Okay, so now it means this is mass V final minus mass V initial over our change in time. So now what is mv? We know that mv is equals to p, which is momentum. So what is momentum final minus momentum initial? So we know that is equals to change in momentum. So it means change in momentum over change in t is equals to F net. Okay, so now it means this is Newton's second law of motion in terms of momentum. So it says F net is equals to change in p over change in time. So this Newton's law of motion can be used to find the object's acceleration due to the net force. Okay, and also the object's change in momentum due to the net force. Okay, so now you just have to know the relationship between the quantities here. All right, so to see how this formula applies or works, let's look at this example here, or this scenario. So we're having two cars, car A and car B. Okay, these two cars are so identical. They have the same mass and then the same velocity, and they are traveling in the same direction towards the wall. So eventually, when the two cars are traveling towards the wall, they are going to crash on this wall, and their velocity is going to be zero. It means the wall is going to make the two cars to come to a stop. Okay, so now you realize that the two cars have the same mass and velocity. It means that their change in momentum for car A and car B is the same. So change in momentum for A is equal to change in momentum for car B, because they are having the same mass and velocity, even they are traveling the same direction. So it means now, if now the change in momentum is the same for both cars, so we've talked about this. If this is the same, then how does the net force be affected over time? Okay, so now car A has a condition that it has no airbags and the driver did not put on the seat belt. And then car B has the airbags and the driver had put on the seat belt on. All right, so it means car A is an old model car, and then car B is a modern generation car. Okay, so now we want to know how the drivers will be affected when the cars hit the wall. Immediately when the cars hit the wall. Okay, so because car A has no airbags, it means that when the car immediately hit the wall, the driver will experience a larger force. Okay, so the driver in car A, for car A, the driver will experience a larger force. When we say the driver will experience a larger force, we mean that obviously the car does not have airbags. It means the driver will get injured so easily and fast. So it means driver in the car, in the A car, will come to a stop first, because obviously he did not put on the seatbelt. If the car crashes, and then he will crash on the steering and other things in the car. So he will experience a larger force. Hence, if you did not put on your seatbelt and the car has no airbags, the more chances that you sustain injuries, there are greater chances for that. Okay, so for car B, because it has airbags and also the driver had put on the seatbelt, when it immediately hits on the wall, or when the car comes to a stop there, the driver in that car will stop over a longer period because of the effect of the seatbelt and the airbag. So it means the time taken for the velocity to be zero, it's a lot slower compared to the driver in car A. Okay, so now what the formula is trying to tell us is that Fnet is equals to change in P over change in time. Okay, we're having the same change in momentum. Okay, so now if we say that the driver in A will come to a stop first, because obviously will crash first compared to this one, because here when it crashes the airbag will open and the seatbelt will try to hold the driver in the car. Okay, so it means the driver in A will experience a larger force. Okay, so if the force is larger, then it means the time taken is so, it says small. That's what, if the time taken for that action to happen, or that force to be experienced, then it will be a larger force because of the time taken. Okay, so what they are trying to do with the modern cars is that they want to try by all means to make the time of impact, okay, they want to make the time of impact, which is this time here, to be larger. Because if the time is larger, then it decreases the force of impact, or the force that the people in the car will experience. So let's suppose we are having our change in momentum to be 40. Okay, and then we have our changing t for car A to be 0.2 second. Okay, and then for this for car A, then for changing P for B is the same one, it's 40. Okay, and then the changing time, because that one has airbags, obviously the driver will not crash immediately, but it will take a longer time. Let's suppose it takes 1.4 seconds. Okay, so when we calculate this, I want to show you the effect of time. All right, so when we calculate the force of impact here, it means we're going to have F net is equals to change in P over change in time. Okay, so now we substitute 40 here and then divide by 0.2 second. So this will give you 200 newtons. So this will be the force that will be experienced if the time taken was 0.2 second. So it means you can see that this is a smaller time, and it brings on what, a larger force of impact. Okay, so if we do similarly for for car B, it means that Fnet will be equals to change in P over change in T. All right. So it means our change in momentum will stay the same because we want to see the effect of time on the force of impact. Okay. So now it means we're going to divide that by 1 comma 4. So we take our calculator and then we take 40, we divide it by 1.4 seconds. And then we get that to be 28.57 newtons. So you can see that when we have a greater time, this time lowers the force of impact. It means if you were in car A, you were going to experience more force compared to someone who is in car B. Because now in car B, because of the effect of the airbags and the seat belt, it took a longer time to bring the person or the driver to a stop. But in car A, because there are no airbags, it means immediately when the car crashes, the driver will experience force, and which is the force of impact. So you can see that when there is a shorter time, then it means the force of impact will be large. But the more the time, then the less the force of impact. So the technology and the airbags today, they're trying to make the time as large as possible so that the force of impact will decrease. Okay, so people won't get too much injuries when they are involved in car accident. So similarly, if you can check, it's the same thing as you are falling from a plane. Okay, same mass, same velocity. We're going down, all of us, same mass, same velocity. And then for person A will hit the ground. This is the ground. Okay. And then for person B, this is the ground, but on the ground, there is a jumping castle or a rubber mat. Okay. So you can see that when this person reaches the ground, exactly the ground, obviously the bones will be crushed and everything. So it means this person will experience a larger force because immediately when the person hits the ground, he or she will experience a force over a short period. But when this person hits the ground, he or she will be supported by this rubber mattress here. I don't know if it makes sense or what, but obviously the person who has a more chance of survival, it's person B. I hope this formula of Fnet is equals to change in P over change in time now makes sense. Okay, because now we were in the industry of car manufacturers and now we're analyzing a different scenario. But this is what the formula is trying to tell us, that if the time of impact it's so small, then the force of impact will be large. If this becomes small, then this one will increase. But if our time becomes larger, then the force of impact will be decreased in that way.